So just a quick wrap up of what we did at the end of class with regards to integrating one function and a power series to get another. And textbook number 45, I showed you the details of integrating term by term, but I just want to summarize here because I felt like we were too rushed at the end, especially the 9 o'clock section. So you've got g of x and f of x, and they're defined for you. And if you notice that f of x is, if you integrate f of x, you get a multiple of g of x. So the integral of f of x is actually negative 1/3 of g of x. So g of x is equal to negative 3 times the integral of f of x. So notice that f of x is the geometric series with x equaling 3x. So we know the definition of the geometric series is here. I'm going to pause for a minute. So to wrap up, f of s is a geometric series of f of 3 of x. So the geometric series is represented by this summation. And if we were to integrate that, just manipulate the indices, the integral of that would be the sum from k equals 0 to infinity, right? You take your index, you add 1, so it's 3x k plus 1 over k plus 1. And when you saw the expansion that we did in integrating term by term and then pulled it together in summation formula, you know, that was the answer that you got. So hope that helps explain things a little bit. Oh, it's minus 3. Oh, let me back that up. So let me just, this was minus 3 times, right, the integral of f of x. So here's the integral of f of x, and of course here is negative 3. Pulling that into summation, it would be equal to minus the integral. If I'm going to move the index to 1, I'm going to add 1 on the bottom. I'm going to subtract 1 on the summations, on the summand, and this becomes this, which is a geometric series, so it's going to converge for negative 1/3 x, and then you need to verify by the endpoints. And why do you need to check the endpoints? Because there's no guarantees with the theorem. The theorem only guarantees interior points. So you did need to go on further and test the endpoints, and we did this in class. And x is equal to negative 1/3, and x was equal to 1/3, produced an alternate harmonic and a harmonic. I produced an alternate harmonic, and that converged, and this was simply the harmonic, and that diverged. So I therefore was equal to negative 1/3, 1/3. So in class we went through the manipulation, we integrated term by term, and then we took the summation. You don't need to do that. You can manipulate the power series as long as you have the a recognizable substitution. Hopefully that helps. I'm going to send one on differentiation.